students, in this video we are going to see how to plot the signal by knowing its equation in terms of standard functions, and once we obtain the signal x of t, we will find out even and odd part. So the equation of signal is given like this: x of t equal to u of t minus r of t minus 1 plus 2 r of t minus 2 minus r of t minus 3 minus u of t minus 4. So quite a big equation we are having. So let's find out its plot. And then we will obtain even and odd part. So what we'll do here, we will add two equations at the time, and whatever the result we will get, we will keep on adding to the third, fourth, fifth function likewise. So first we will add u of t and minus r of t minus 1. So u of t is like this. It's a unit step, means it will have the magnitude 1. Second function we are having r of t minus 1, shows a shifted ramp with magnitude 1, meaning at t equal to 2 it will reach a value equal to 1. So the slope of this line is 1. So this is r of t minus 1 because it is a shifted ramp. We need to subtract these two functions to get a resultant. So the subtraction of these two functions will get a resultant like this. So once again, at 0 it will have the value 1 because nothing is there from ramp side, only step will have the magnitude 1. So it's quite obvious, from 0 to 1 value is 1, and this particular line is having slope 0. So see how we are going to do this. From 0 to 1, this particular function is having magnitude 1 and slope 0 because it is parallel to t axis, so obviously slope is 0. 0 to 1 over here, there is no magnitude, so magnitude is 0, so there is no question of having any slope. So in the end, what we should get from 0 to 1, we need to subtract magnitude and we need to subtract slope. So 1 minus 0, magnitude will be 1. 0 minus 0, slope should be 0. Meaning I will get a resultant function like this. So this is what a function where magnitude is 1 and slope is 0. Let's go ahead from 1 to 2. Being a step function, here once again magnitude is 1 and slope is 0, but this time for the ramp we are having slope which is equal to 1, and at the end of a t equal to 2, this particular function will reach the magnitude equal to 1. So now what we have to do from 1 to 2, basically at t equal to 2, magnitude is 1, here also magnitude is 1. So in the end, for t equal to 2, I should get magnitude 0, but slope will be 0 minus 1. So from 1 to 2, I should get a negative 1 slope, and at t equal to 2, value should be 0. So that is possible only if I draw line like this, which will tell this is of slope minus 1, and at the end of t equal to 2, magnitude is 0. And what will happen thereafter? Thereafter, this line will be continuing. What is the same for this line? Slope, which is equal to minus 1, but magnitude will keep on changing because of this ramp. So resultant of these two signal will be like this. So for this signal, we need to add 2r of t minus 2. So this signal we are after now. This signal, which is u of t minus r of t minus 1, we need to add with 2r of t minus 2. T minus 2, so it's a shifted ramp, and it is shifted or delayed by 2 units, and magnitude is 2, means this ramp will have the slope 2. So basically, this is the ramp that we are talking about. Its slope is 2. Now we need to check what will be the resultant. Which will I will write it first. So the resultant will be like this: u of t minus r of t minus 1 plus 2r of t minus 2. See once again, 0 to 2, there is no signal exists for this. So 0 to 2, whatever we obtain will be same. So 0 to 2 signal will be like this. Now we need to check what will happen 2 onwards. So over here, for 2, magnitude is 0 and slope is minus 1. At 2, for 2r of t minus 2, yes, magnitude is 0, but slope is 2 thereafter. So if I add the magnitude, it will be 0 only. This is a place. But slope will become minus 1 plus 2, which is plus 1. So increased slope we will get. And same thing will be continued thereafter, because every time this slope will add and it will give you answer 1. So what I can say, 2 onwards, I will get a line whose slope will be 1. So we'll get a line like this with slope equal to 1. So I can write this section, I can say will have the slope plus 1. That is what the outcome of addition of these two. Now next signal is this minus r of t minus 3. This signal we need to add with the resultant. Let's see how signal will change. So we are having this signal. Which is u of t minus r of t minus 1 plus 2 r of t minus 2, which we need to subtract with r of t minus 3. So r of t minus 3 is nothing but delay ramp by 3 units. Delayed by 3 units with slope 1. So we'll get this, which is r of t minus 3, and we need to subtract r of t minus 3 from this signal. Let's see what will be the resultant signal. From 0 to 3, nothing will change. So absolutely same signal we will get. Meaning the signal will get like this. It will have the value 1 from 0 to 1. Then it is a negative ramp of slope minus 1. Then it is a positive ramp of slope 1. And then we need to check how this signal will affect the final signal. So at t equal to 3, here I can say magnitude is 1 and slope is also 1. Shifted ramp by 3 units will have the magnitude 0, but slope of this ramp is plus 1. So we need to subtract this. So 1 minus 0 is 1, that we already obtained. Now we need to decide about slope. Slope 1, here also slope 1, subtraction will become slope 0. So in the end, what we should get? Slope is getting cancelled, but magnitude over here is 1, later on it become 2, 3, like that. Whereas this becomes 0, 1, 2. So even if I do the subtraction, the magnitude will always have a difference 1 and slope will become 0. So 3 onwards, I should have a magnitude 1, slope 0. That means I should get a line parallel to t-axis with a magnitude equal to 1. So this is what the resultant signal we will get, which is nothing but u of t r of t minus 1 plus 2 r of t minus 2 minus r of t minus 3. This signal, now finally we have to do subtraction with u of t minus 4. So let's do it quickly. So this signal we obtain, which is nothing but u of t minus r of t minus 1 plus 2 r of t minus 2 minus r of t minus 3, and this we need to do subtraction with u of t minus 4, which is nothing but a time delayed unit step function. So it will be like this. It will have the value from t equal to 4 onwards. So let's see how the final signal we will obtain, which is nothing but x of t. From 0 to 4, same signal will obtain like this, because here no signal exists. Now what happened at t equal to 4? For this signal t equal to 4, I am having magnitude as 1 and slope as 0, because it's a flat line. Unit step at t equal to 4 will have the magnitude 1 and slope 0. So when you do subtraction, so 1 minus 1, magnitude should become 0, at the same time slope should also become 0, and it should remain 0 magnitude 0 slope t equal to 4 onwards. So that can be obtained just by drawing this vertical line, and henceforth it will become a 0 magnitude and 0 slope. So in the end, this signal we will obtain, which is nothing but u of t minus r of t minus 1 plus 2 r of t minus 2 minus r of t minus 3 minus u of t minus 4, and which is nothing but x of t. So we have seen how the different types of standard signals can be given in an equation, and once we know all this theory of magnitude and slope, only a subtraction and addition of magnitude and slope particular instant if you do, in the end we will get a resultant signal. Now we have x of t like this. Now from this we have to get a even and odd part of it. So let's first find out the time reverse of x of t. We'll get a signal like this. And we need to add x of minus t and x of t to get a even part, and for odd part x of t minus x of minus t. So let's find out the even part. So if I add the signals, we will get signals like this. And now this x of t plus x of minus t, we need to divide by 2 to get an even part. So even part of x of t will be like this. As far as shape is concerned, it is absolutely same as the previous signal. Only thing is that magnitude we will get is a 0.5. So signal will be like this. There won't be any change as far as the shape is concerned. So this is a even part of the signal. Let's find out the odd part. So for odd part, we need to find out x of t minus x of minus t. Which we obtain like this. So we'll get a signal like this. If this signal is divided by 2, then odd part of a signal is obtained as follows. So this is the even part, this is the odd part, and if I add these two, we will get a original signal x of t. So in this video, we have seen a complicated equation given in terms of a standard signals. Still, we will obtain x of t by just adding, subtracting magnitude and slope in order to get a final signal. And once final signal is obtained, we can get even and odd part. Thank you.